Find the coefficient a, b, and c so that y equals ax cubed plus bx squared plus cx has the local maximum at x equals 3 and the local minimum at x equals -1. Also, the inflection point at 1, 11. The point 1, 11 implies that when x equals 1, y equals 11, we're looking for a, b, and c. These are three unknowns, so we would need to have three equations. The first point 1, 11 give us one equation already. 11 equals a 1 cubed plus b 1 squared plus c times 1. This is 11 equals a plus b plus c, which is one equation already. The fact that f has a local maximum at x equals 3 means that f prime of 3 must be 0, and f has a local minimum at x equals -1 means that f prime of -1 is 0 as well, using Fermat's Little theorem. But if f of x or y equals ax cubed plus bx squared plus cx, then f prime of x is y prime 3ax squared plus 2bx plus c. When we plug -1 into the first derivative, we will get 3 times a times -1 squared plus 2b times -1 plus c, and this needs to be 0. So we obtain the second equation. 0 equals 3a minus 2b plus c. If we plugged in 3 into the first derivative, we have 3a times 3 squared plus 2b times 3 plus c, and it needs to be 0 as well. So we obtain the third equation. 0 equals 3 squared times 3 is 27, 2 times 3 is 6, and we still have plus c. This is the system of three equations with three unknowns, a, b, and c. So we should be able to find a, b, and c using elimination or substitution method. Using the last two equations, taking the second equation minus the third equation, we have 0 equals 3 minus 27 is minus 24, combined like terms. Minus 2 minus 6 is minus 8. C minus c is 0. We then use the first two equations. Taking equation 1 minus equation 2, we have 11 equals 8 minus 3a is -2a. b minus -2b is plus 3b, and c minus c is 0. We now have a system of two equations and two unknowns. To eliminate one variable, we see that 24a is a multiple of 2a. In fact, we take the second equation times 12 to get a new system of equation which is equivalent to this system of equation. Leave the first equation alone. 0 equals -24a minus 8b. The second equation is now 11 times 12 is 132. -2a times 12 is -24a. 3b times 12 is 36b. We then take the first equation minus the second equation. 0 minus 132 is -132. Negative 24 minus negative 24 canceled out. Negative 8 minus 36 is negative 44. And this is negative 44b. b is negative 132 divided by negative 44, which is positive 3. So we found b equals 3. Now we can do a back substitution by going back. We have b equals 3. Using any equation with a and b, we can find a. Using the equation 11 equals negative 2a plus 3b, but b is 3 now. We have 11 equals negative 2a plus 9. 2a to the left equals 9 minus 11, so 2a equals negative 2 and a equals negative 1. With b equals 3 and a equals negative 1, we go back and do a back substitution, any equation with 3 variables now. 11 equals a plus b plus c, where a is negative 1, b is 3, and c is still unknown. This is 11 equal 2 plus c, so c equals 9. These are the 3 constants a, b, and c that we need to find. The function that we should have started with was y equals negative x cubed plus 3x squared plus 9x, where a is negative 1, b is 3, and c is 9.